Okay, this video is on section 2.7, which is on rational functions. We've been talking about polynomials. So our unit was polynomial and rational functions. So rational functions is a little bit different. So a rational function is written in this form. F of x is equal to P of x over Q of x. And P of x and Q of x are polynomials. So it's essentially two of the equations we've been looking at, written one in the numerator, one in the denominator. Okay, you have some stipulations on them. Q of x cannot be 0, otherwise that would be something we wouldn't be able to graph. And P of x and Q of x cannot have any common factors. Okay, we have talked about rational functions in our first unit. And actually the parent function, or the most basic rational function, is f of x equals 1 over x. Okay? And it's graphed in green right there. Okay? So it is a rational function because 1 is a polynomial, okay, and x is a polynomial. Notice it does not go through the origin at all. And you're going to be able to graph these types of functions when we get done with this video and our learning in class. So, the domain. You're going to have to be able to identify the domain. And you did this before, okay? The domain is all real numbers except where Q of x equals 0. And remember, Q of x is the denominator. So the domain, you could input anything into that function except where Q of x is equal to 0. So if, for example, I had that G of x was equal to x plus 3 over x squared minus 4, you'll see I went ahead and factored the denominator. That's important, okay? We cannot have any common factors between the numerator and the denominator, and we don't here. So if I wanted to list the domain of this function, it would be anywhere except where Q of x equals 0. So where does the bottom equal 0? 2 and negative 2. So we would say that the domain is all real numbers except 2 and negative 2. So you need to be able to identify the domain. So again, it's all real numbers except where their denominator is equal to 0. Okay, so we're going to have to identify the domain. Then we're going to have to be able to identify the asymptotes of rational functions, okay? The asymptotes help us to determine some behavior, okay, about our functions. Okay, the vertical asymptotes, those are x equals equations. So you want to make sure you're denoting them with x equals. And this is where Q of x equals 0. So again, Q of x is our denominator. So if I wanted to find a vertical asymptote, I would set Q of x equal to 0, just that part of my equation or function, and figure out where it equals 0. Horizontal asymptotes. Those are y equals lines. So you're going to make sure you want to denote that when you are telling me the equations of your asymptotes. Okay? And these have 3 rules that go with them, and you've probably seen them before. You either are going to have one or no asymptotes. Okay? And here's our first rule. If the degree of the numerator is less than the degree of the denominator, your asymptote is at y equals 0. Okay? So you're going to have to find the highest degree in the numerator, and if it's less than the highest degree in the denominator, then it's going to equal 0. Okay? Second one, if the degree of the numerator equals the degree of the denominator, so both of them are x cubed, then you have y equals the coefficient of the numerator divided by the coefficient of the denominator. So you would find your highest degree and you would divide by the number in front of each, and that would give you where you would graph at. And we'll do an example of that in a second, but just go ahead and write it down. So if they equal each other, you have to look at their coefficients. All right? Then the last one is if the degree of the numerator is greater than, so this is kind of the opposite of Rule 1, then there is no horizontal asymptote. Okay, so again, those are your 3 rules. You're going to have to know these. So if the numerator is less than the denominator, it's y equals 0. If they equal each other, you're going to find the coefficients and divide by those. And if the numerator is greater, then it's none. All right, so on page 272, it will go through all of your steps to graphing a rational function, and I'm about to get to the note sheet that I handed out to you. It also lists, if you look at that, okay, how to graph. You're going to have to find the x and y intercepts. Then you'll have to find the vertical and horizontal asymptotes, and we just talked about those. Then you are going to have to decide, do I need any additional points to graph it? Then I'll actually graph, and then the last thing is I'm going to identify the domain. So you have quite a few steps to go through for these problems. But let's make sure we remember how to do all this stuff. So if I'm going to find the y-intercept, I'd want to have 0 and then my y. So I'm going to set x equal to 0 and solve. Again, this is something we talked about in Unit 1, and you've seen before pre-calc, so this should be some review. Okay? If you're going to find the x-intercept, you're trying to find where x is equal. So I'm going to set y equal to 0 and solve. I want to find those points along the x-axis. So y is going to be 0, not going up or down at all. Okay? Then I'm going to find the vertical asymptotes. So that's x equals. And here I said set the denominator equal to 0 and solve. Okay? We've already went through that one. You've already taken notes on it. So then the next one is going to be to find your horizontal asymptotes. That's y equals 0. You're going to use your 3 rules. 5, you have to plot any additional points in order to feel comfortable that you can draw your curve in. Okay, so we have quite a few things we have to do here, but this is how you graph a rational function. This is on page 272. If you forget the steps, again, they're on the note sheet that I'm about to go to and do a couple of examples for you. But I just wanted, if you have forgotten how to find a y-intercept, then I kind of just quickly went through how you do that. Okay? So you might want these out as you're going through the note sheet with me, because if it says find a y-intercept and you don't remember how to do that, then you're going to reference back to these steps here. Okay? So what's going to happen is I think I might pick 1 or 2 problems off of this paper. There are 6 of them, and we will see how we're doing after 1 or 2 problems. Okay? So let's do number 4 to start. So go to number 4. We're going to graph this. It's y equals x over x squared minus 9. Okay? And again, here are my steps that I'm going to have to do to solve this. So the first thing I have to do is find the x and y intercepts. So I'm going to go to another sheet of paper. This is not enough room for me to write. So our equation all right, so part A, find the x-intercepts. So I set y equal to 0 and solve. So 0 is equal to x over x squared minus 9. And if I want to solve this, then I would technically multiply both sides by x squared minus 9. Okay, because that would cancel my x squared minus 9, x squared minus 9. And then 0 times this, I should just have 0 equals x. So that means my x-intercept is at 0, 0. Okay? So my x-intercept is at 0, 0. Sorry, you can't see that. Okay? That's part A. Part B, if you're looking at your paper, says to find the y-intercept. And to do that, I set x equal to 0 and solve. All right? So I go ahead and do all this. 0 divided by 0 squared minus 9. So I've got 0 divided by negative 9, which is 0. So my y-intercept is also 0, 0. Now that's not always going to happen. Okay? We've done A and B, and these actually are the exact same point. Again, that's not always going to happen. There can also be multiple intercepts, so be careful. Okay? Part C, I'm supposed to find the vertical asymptote. So if you don't remember how to do that, look back in the notes that we took, but I'm going to remind you again. Vertical asymptotes, I set the denominator equal to 0. So I just take x squared minus 9 and set it equal to 0. Now, I can just factor this, or I can go ahead and solve it by square roots. X squared equals 9. So x is going to equal plus and minus the square root of 9. So x is going to equal plus and minus 3. So I would say my vertical asymptotes are at x equals 3 and x equals negative 3. Sorry, that got kind of messy. All right. Letter D on that paper says to find the horizontal asymptotes. All right. To find the horizontal asymptotes, I have to use my 3 rules. So the degree of my numerator, if you go back up here, degree of my numerator is 1. The degree of my denominator is 2. So that means the degree of my numerator is less than the degree of my denominator. So using my 3 rules, my horizontal asymptote is at y equals 0. Remember, to figure those out, you just use your 3 rules. Okay? Now, letter E says to plot any additional points, but you're not going to know if you need additional points until you plot the information that you have. So we're going to go to our graph, and we're going to plot all this. So keep this paper out. We're going to first start by plotting our intercepts, and that's at 0, 0. And I'm doing problem number 4. So go to the back. Okay? So I've got that there. There's the equation I'm graphing. Okay. Now, I also need to plot my asymptotes. Okay? So I had a vertical one at 3 and negative 3. So that would be about right here. All right, and if you notice, I also had a horizontal one at y equals 0. Okay? If you notice, this essentially, these verticals divided my graph up into 3 separate pieces, and I need to be able to sketch what it looks like in 3 separate pieces. So that means I'm going to have to pick some points from here, some points from here, and some points from here in order to figure out what this looks like. So, going back to my paper for part E, I'm probably going to draw an XY table. All right, and looking at this, we'll start with the far left. I think I'm going to pick -10 and -6. All right, then for this middle section, I think I'm going to pick -2 and +2. And then for my last section, it's at 3. So I think I'm going to pick 4 and 8. I ran out of space, but. All right, so I've got 2 XY tables going here. Remember, your original equation is x over x squared minus 9. Okay? So, I've got to figure out what is this going to look like. So, -10 squared would be 100, minus 9 be 91. So, I've got 10 over 91. Okay? Then here, and it's negative, sorry. Okay? And then I would have -6 over 36 minus 9 would be 27. Sorry, guys. All right, and then -2 over -5, so that's +2/5 actually. Okay. Then I've got 2 over -5, so that's -2/5. 4 okay, and then I've got 8 squared, which is 64 minus 9. So we've got 8 over 55. Okay, so I've got some numbers to graph. I think I need to go back to my 4. So this would be 4, and then 4 squared would be 16 minus 9. I'm losing it. It's Friday. 4/7. Okay? So let's go back over to our graph. And the first point we need to plot is -10, -10 over 91. And I think what's important is that you just recognize that that's less than 1. Okay? So it's got to be about right there. -6 over 27. Now let's compare those fractions. Okay, and then my next one was -6 divided by 27. So which one of those is the smaller number? Okay, this first one. I'm sorry, my second one's smaller because we're in the negatives. Okay, so -6 is going to go down a little bit. Okay, now look, here's an asymptote. So the behavior of this is to go through these points, and it's going to keep getting closer and closer to that line, but it will never cross my vertical asymptote. So that's what that looks like in that piece. All right, now my middle, that's where I had -2 and 2. So -2, it's at +2/5. All right, and a +2, it's at -2/5. All right, now it's kind of hard to tell what's happening here, but I know for a fact that this is going to get close to my asymptote but never cross. Same here, it's going to get close to my asymptote and never cross. Okay, there's what that looks like. Now let's do our last piece. So at 4, I was at 4/7, which is definitely less than 1. Then at 8, I was at 8/55, which is a fraction that is smaller. So it's going to do this, and it's going to get close to that asymptote, but it's not going to cross. All right, so that's what that graph looks like. Use the asymptotes to help you figure out what the graph looks like. What I would like for you to do is I would like for you to go back to the front. There are 6 problems on here. I've done 1 of them. I would like for you to pick 2, and on Tuesday you're going to come with 2 of them graphed, or you're going to come to class with 2 of them graphed. Just try it, and you really need to try it without looking at your graphing calculator, because this will be on a no calculator portion of your test. Okay? You'll be able to use a small calculator, but not a graphing one. So try to do them without your graphing calculator, and then use that to help you if you need to. Good luck.